Hello everyone, this video is the first on this tutorial series where we're going to use PANORAmake to texture a simple landscape from an empty instance to the result you see here. This landscape has been textured in around 2 hours using pre-made assets. In this tutorial, a lot of PANORAmake's functions will be shown, such as basic texture editing, mask creation and linking, etc. Before we proceed, you need to have your PANORAmake plugin installed and the instance created and set up on your landscape. The previous tutorial covers all of that and can be found in the description. First off, we will add a plane of water to our landscape. To do that, we'll open the Place Actor tab, then drag and drop a plane into the scene. We'll place it and adjust its size for now. We'll place other water planes later on, but we'll focus on this one for now. We are using pre-made assets, so I will just pick a water material for it. Now we will open the Builder interface and start editing our instance. Click it and select the landscape at the bottom. Once opened, you can see the sublayers to the left of the interface. We are currently on the base layer. We'll rename this layer Grass so that we can keep track of what we're doing and change the base color texture. Changing texture is as simple as that. What I'll do is clicking the folder icon next to the texture preview. That will open the folder where it is located, and I will select the normal and value maps for this initial grass layer. Clicking the arrows icon on the preview will set the currently selected texture from the content browser. Now, as we only have a unique roughness map, we'll disable the usage of packed textures and disable the usage of the occlusion map. Once again, with the roughness map selected in the content browser, we'll click the arrows button on the roughness preview to set the selected texture. The warning and the button next to the preview are here to warn us if our texture isn't using the correct compression format. In this case, this texture should be a NOMS RGB grayscale map, as it's only a value map using a single channel. Clicking the button will bring up a message asking if we want to convert it. This is important to ensure correct roughness values in our case. However, this will break materials that already were using this texture incorrectly. We now have our grass, but let's add a bit of variety to it. We can go into the Effect tab to add a noise-based darkening effect to break the uniformity of the material. The effects are meant to be simple, one-click features. In this case, we just have to enable them and choose how dark or light we want the affected area to be. It looks better, but the effect is a bit strong. We will edit the noise used so that the effect can be a bit more subtle. We will edit contrast and force settings. The lower the contrast is, the less defined the noise will be. Force is how strong it will be. The noise is set up as we want. We can edit the lightness value in the effect settings. This setting sets up how dark or light the effect will be. We'll leave it up as its default value of 0.7, as we've already adjusted the effect using the noise settings. Now we're done with the base grass layer. We will create a new dirt layer on top of this one. We'll rename the first sublayer to General Dirt. When you hover on top of the sublayer buttons, a small tooltip showing its preview and name will be shown to help you navigating in the instance. We will make another material on the borders of the water plains, based on the height of the terrain. We'll name it Sand. Wait for it. We will need a dirt ground texture. Now we'll need to create our mask for automatically assigning this material. They can be set up in the Mask tab, the first one. First off, we want dirt to be applied around our water plains. Scroll down and enable the height-based filter. We'll need to set up the desired height values. We can place an actor in the scene, select it, and click the Pick from Selected button to set our height values based on it. Once set, we'll need to adjust the fade amount and invert the height value. The fade amount needs to be adjusted alongside the Z transition value to get the desired results. Our height is correctly set, and we'll add a slope-based filter alongside it. Once again, we'll need to adjust its settings to get the results we want. The steepness value in the slope filter sets how steep the slope has to be for applying the effect. The lower the value, the less steep it has to be. The contrast setting, as its name suggests, contrasts the effect. Both can be tweaked to get the desired results. As we use the height-based mask, it also affected other areas that are the same height. You can manually paint a sub-layer instead if this isn't the desired result. In our case, that's okay, we'll add more water planes. We'll quickly set the value textures for our dirt. Once again, we can click the folder to get in the textures directory and manually select them with the arrows buttons. Do not forget to set the texture compression type accordingly if needed. Remember that it will break the materials using the texture incorrectly. We'll just change the height values a bit. Then let's make our sand material that is even closer to the water. We'll use the second sublayer and set good textures for our instance. Once again, picking textures, setting up values like the previous ones. Now we'll use the height-based filter on this sand sublayer that with lower values. We can just select the water plane and click the Use from Selected button to get the height quickly. We have no occlusion map on the material, so we will toggle it off. We just need to adjust the values a bit. The height is okay, but wet sand is usually darker and shinier. We will adjust its color and roughness value with the map adjustments. Looks good to me. Now our basic dirt looks a bit flat. Just like the grass, we'll use a noise-based darkening effect with it. No need to change the effects values, it's fine by default. What needs to be adjusted, however, is the timing of the dirt layer, which is too visible. We can just toggle the UV breaking feature in the material to quickly fix it. It's as simple as that. Just applying some finishing touches. The occlusion map doesn't seem to change a whole lot, so I'll just toggle it off. Our dirt material is done. Now we'll add more dirt randomly on the train trough the use of the random noise filter in the dirt's mask settings. That's too much by default. We'll adjust the values to reduce how much dirt there is splattered around. The default noise map used in the instances is a packed map with a different noise pattern in its RGB channels. We can choose which channel of the map to use by ticking the wanted layer in the Layer to Use section. The alpha channel of the default noise map is empty, but it is usable if you want to use your own noise map. You can change it in the global options. Every feature using a noise map has UV breaking available, offering more interesting noise patterns. It can be toggled off if not wanted. This big zone is a result of using UV breaking with the noise filter. Now we'll add another layer with a different kind of mossy grass for additional detail. So let's look for other grass textures. The grass texture has its alpha compression enabled. I will toggle it off for optimization purposes. For the other maps, same as usual. Now for the mask, we'll want our secondary mossy grass to be applied on pretty flat, non-sloped surfaces. To better see what we're working on, PANORAmake features a mask visualization view called LOOKDEV View. To enable it, you can click the I button under the preview image. The colors show which sublayer is visible. Black is the base layer and by default red is the sublayer 1. In our case the dirt, green is the sublayer 2, in our case the sand, etc. The colors can be changed at the top of the mask settings with the LOOKDEV mask color option. For a reverse slope effect like what we want, it's better to go with the advanced mode. When toggled, the slope is calculated by a minimum and maximum angle value. We still can invert and change its contrast though. We'll need to invert the slope and then get a good looking effect by editing the values. In our case, we actually just need to change the contrast value a bit. And now, to get randomness and not having this new grass basically replace the base layer, we will use the noise-based filter. The filter is set, but the slope is generated on top of the noise. Instead of adding the slope filter on top of previous masks, we can multiply it by the noise so that it only applies on the areas designated by the noise. This feature is very useful for creating advanced masks that rely on multiple filters. As our slope is multiplied by the noise filter is the master and is the one that is being edited to change the mask's look. The material's normal matte strength can be edited with the normal flatness value in the map adjustments. Values under 0 strengthens it, over 0 flattens it. There is one more thing we overlooked and need to fix. The mossy grass layer gets applied on top of our sandy shore sublayer. The fix is fairly simple. We just need to add a height-based filter, like the one that defines the sand sublayer, and tell it to subtract itself from the final mask. A very useful function is the mask linker. By clicking the chain icon, filters can be linked together so that the link filter gets its values and settings copied from the master filter. If the master filter is edited, a linked filter will get its settings updated. The linked filter can then be set to add, multiply, or subtract itself from the rest of the mask. In our case, we want it to subtract itself. We just need to click the minus button. And that's it. The landscape lacks a bit of dirt. Let's quickly raise our dirt slope value. And now we'll make a new sublayer for a rocky cliff material, which will be defined by steeper slopes. We'll name it Rocks. Let's tweak our values to get something that suits us. Now that we see what we're doing, we can make the material as usual. It's important that the color suits the global landscape. We can test a few adjustments to get different looks. The result is okay. Now what could be interesting is having the rock layer show up only on one side of the slopes. For that we can use the directional filter and multiply the slope filter with it. That way the mask will only affect one side of the slopes. I'll just insert a big value in the slope filter so that we only see the directional one for now. As the directional filter will be the base getting multiplied with the slope, it needs to be strong enough so that the final result is well visible. With everything together, we now have the rock layer only on one side of our slopes. We can make small adjustments to our rock color. And to our dirt mask settings. Next, to get our rock layer a bit less uniform, we can use a darkening effect once again. But this time, we'll use a normal spaced effect. The normals-based effect used the normals of the terrain to determine the area to darken or lighten. Basically, the steeper the slope is, the darker or lighter the zone will be. The lightness setting works in the same way as the noise-based darkening effect. And we are done with this basic terrain texturing. We saw a good amount of features in this first video, like how to use the interface, using the filters and blending them, mask blinking, using the LOOKDEV View, etc. In the next video, we'll see how to apply grass meshes with PANORAmake, and we'll use the grass settings it offers. Thank you for watching.